Hello, can you all hear me? Yeah, I had a doubt in a question from previous week's assignment. Okay, I'll start with your question. Okay, Ananya, you stay in the call. We'll start with your questions. Okay, your doubt. Okay, yeah. Yeah, so we'll start with one question asked in the chat box. So before that, so this will be tutorial, your tutorial of week 4. So but before that, we'll start with a doubt which is asked in the chat box. Okay. So Ananya, can you please tell me just whether it's correct whatever I'm writing? Yes. Yeah. So is it the question is like that x cube y over what is the question?
Sir, x y cube over x minus y.
X y cube over x minus y. Yeah.
This is when yes, this is when x y are not equal to 0, 0.
X not equal to y, I think.
No, sir, x comma y is not equal to 0, 0.
Where was your question? This question x y not equal to
Not
0 0 you are telling.
yes, sir. So this question was in last week's assignment, week 3's assignment. Question number 6.
So was it x minus y?
No, sir, I'm sure it's x comma y in the new.
Yeah, I think then there will be a mistake. So because you see, even though not xy not equal to 0, if x equal to y, then also this x y cube over x minus y is not defined.
Exactly, sir. And the question is that we have to, there are four options that the function is differentiable, it is not differentiable, and satisfies necessary conditions and does not and satisfies sufficient conditions. So I did, since it is not continuous at 0, 0, I marked that the function is not differentiable at 0, 0, but the answer is wrong. And the correct answer is that the necessary conditions, it satisfies necessary conditions, sufficient conditions, and it is differentiable at 0, 0.
Yeah, so this one, it is first of all the function you have to tell me. So I think the function should be if it is x y cube over x minus y, and it is it when x is not equal to y and 0 when x equal to y. I think the function should be first of all this. Okay. So even then we'll have to check it whether we can show that it is continuous. You think it will be continuous? That is not a problem, right? That you can do
Yes,
it.
sir.
So then you have to find out mainly the fx at 0 0, right? So which will be limit as x tends to 0. So whatever you will get, so that will be f of h 0 minus f of 0 0 over h, and that will give you limit as h tends to 0. What is limit of h0? That is 0, right? Minus 0 over h, so that will be 0. So similarly I think you can show that limit of, sorry, f of y will be, f of y at 0 0 will be also 0. Then if we find out the limit as hk tending to 0 0 for defensibility, I'm mainly going for defensibility, f of hk minus f of 0 0 minus h times fx at 0 which is 0 minus k times f of y which is also 0 over h square plus k square square root of, okay. So what will this give? Limit as hk tends to 0 0. What is f of hk? Will be h k cube over h minus k times square root of h square plus k square, right?
Yes, sir.
That's all. So now, so you have to choose a path in such a way that it will so if we you have to show that this converts to 0, not anything else, okay. So how you would do that? That is the question now. So Yeah, so last week what we did, I'll just check it. So the last week one will be this one. So in which notation I taught, so that I will check once. This is okay. Then this fine. So this is like this only. Okay. Yeah. So what you got is limit does not exist or limit converts to zero, right?
So 0.
So what was the answer? What's the answer?
So actually, that was my doubt in the question which is given in the assignment. We have done this modification of x is not equal to y. In the assignment, the question is given as I originally told you. That was my doubt, and that's why I gotten it wrong. So I wanted to ask.
So what is the answer? Is it differentiable given, right? I will try to then prove instead of just thinking this one.
Yes, sir. This will be differentiable.
Exactly. So yeah, I'll try. Then I have to try to prove that because whatever the see you see, I said that if you take h equal to mk type of path, you will see that will also go to zero. So you cannot prove that using the usual way, the h equal to mk and all that this will not exist and all. So that's why we have to show that this converging to zero mainly. Okay. So for that, I think we should do something. Let's see. Yeah, so HK cube. So, yeah, just 1 minute. Okay. So what we'll do, so you can check with h equal to r cos theta and k equal to r sin theta. Okay. Using that, you can also show because you see this will be the denominator will be so this when you do this that limit will be as r tends to zero. uh, you will get above it will be r square with the 2r you will get here, so this will be r square times cos theta sine cube theta over cos theta minus sine theta. So when cos theta is not equal to sine theta, I mean, of course, when you are assuming this, when cos theta equal to sine theta, I mean, then it is all it is the function is always zero, so you don't need to worry about then that. And when it is not equal to zero, so this as r tends to zero, so other things are whatever the function this will not affect you because those are bounded functions. So I mean, as r tends to zero means it does not depend on r, so it will be zero. So r square times this quantity will be zero, right? So, but when cos theta equal to sin theta, that then function itself is zero because cos theta equal to sin theta mean r cos theta equal to r sin theta, and the x equal to y mean the function is zero. That's how we define the function. So, Ananya, I think you were asking, right? Yeah.
Yes,
So,
sir.
this function should be defined like this. If it is not defined like this, I will check and I will tell you. So I don't see you understand, right? Why? So what is your
Yes,
function?
sir.
You said
I
your function.
understood.
If this is the function, it is not defined along x equal to y line, right?
Right, sir.
Because when x equal to y, then also x equal to y equal to 1, then also it will follow in this domain, but then the function is not defined.
Right, sir.
Right? So the function should be like this. I believe the function should be like this, and then you can follow this to show that the function is differentiable because this limit is tending to zero, which we want, right?
Yes.
You
Clear.
understand?
Yes, sir.
Okay. So any other questions from the last class? You can ask me. I stop for some time.
No, sir.
Okay. So then let's move to the today's topic of discussions. So we'll mainly discuss with all of you know, I think already, that we'll be discussing Taylor's theorem for functions of two variables and the maximum minimum of a function and constraint maxima minima. Okay, these three topics we'll be discussing here. So we have already seen the Taylor's theorem for functions of one variable, and we have seen the function like this function has to be like fx. If f is a function of one variable, then fx will be at a point of, suppose if you have a point a in a domain, then in the neighborhood of that domain the function should be like this: f prime a plus it will keep on going if the function is infinitely differentiable. Otherwise we will have a term like Rn if f is the if has, and this is called a reminder term, mainly a reminder term. We have seen already these things, and this Rn will be looking like this. This f in fact n times derivative or n plus 1 times derivative, so whichever you are taking this at the point a over n plus 1 factorial times this sorry, I think I made a mistake. I'll just correct myself. This will be x minus 1 e to the power n plus 1 times f n plus 1th derivative of a plus theta x. I mean, or the point, and theta is belongs to 0 to 1. I mean, this point will be belong to a to x only. Okay. So when theta equal to 0, this point is a, and theta equal to 1, it is a plus x. So a to a plus x, it has to be belong to that. And from this thing, we can find out the find out for complicated function we can approximate using this Taylor's theorem. So our main idea to approximate the one of the main ideas is to approximate the function using like by polynomial. So you see these things will be a polynomial function. So if you have fx equal to, let's say, e to the power x, then e to the power x will be I think 1 plus x time about 0, this x plus x square by 2 factorial, and it will keep on going. But if you want to take up to certain term, you can write e to the power x is this type of, right, n factorial, like whatever the function will come, I most probably it will come like x to the power n over n factorial. So you can approximate it to the power x by this. So let's say sine of x square also, I mean such type of functions are difficult in general to understand, so you can approximate and you can get the Taylor series of that function, and you can say that it is approximately, and it is close to a polynomial of degree n or polynomial degree n plus 1. So that is what we have seen already. So now we'll move to for the functions of two variable. So if it's a two variable function, you see, and suppose if it is two variable function, its partial derivatives to n plus 1 are continuous, then you can write like this. You have to remember this only. I mean, the remember, not nothing to remember. First will be f of a plus b, and then like in one variable we had x minus a times derivative. Here the derivative is nothing but two derivative, fx and fy you have. And third term again it will be like x minus a plus y minus b, that whole square, that coefficients will come, and 1 over 2 factorial again it is kind of that is same. So for if you want to approximate for second order approximation, then you will have to take up to second order term, second order derivatives. So we'll see all those things just for doing our mathematics, doing our questions. I am telling whatever is needed. Okay, and yeah, these are some applications that you may ask, that why we need this. First of all, this one I said already, to approximate functions by polynomials, and also it will be useful to solve some non-linear or non-linear differential equations using solution series solution. That also you will see later, not in this course maybe, but it will be useful to solve some uh, differential equations which are non-linear in nature, but it's not, and it's difficult also to prove using some other some existing all different tools other than this series solutions. So that's one thing, and another is to approximate integrals, which we will see uh, in this lecture. Okay, in this tutorial session. So let's first start with the first question, which is Taylor's expansion of e to the power xy at 1 up to third degree terms. Okay, so let's start with that. So what will be, what is your f of xy? F of xy is your e to the power xy. Okay, now we have to take up to third order terms. Okay, so for third order terms mean you have to go up to third degree polynomials. Okay, so what you will have this f of xy, I mean at 1 first of all we have to first of all we let's do a derivative. So what will be that? Y times e to the power xy, right? You take derivative with respect to uh, x. So what will be f of y at xy? That will be x times e to the power xy. So similarly, you do some f of xy, which will be y squared time e to the power xy. F of y will be xy equal to x squared time e to the power xy, and f of xy will be xy times e to the power xy. Okay, so and you have to find out what are the values we need up to third degree terms. Okay, see that's a thing. So third degree terms will involve f of x y, I mean f of x, like third derivative of f with respect to x, that will be, I mean, yeah, so at xy that will have some this term. So y cube times it is for xy f of uh, x xy will be y times e to the power xy. So you are taking derivative with respect to x, so it will be y times e to the power xy plus sorry, I forgot here, plus xy times xy square times e to the power xy. So these type of terms you will get. So all these things, all these derivatives we need now. Okay, so what we'll see, so another 10 derivatives we need is y, that will be x cube times e to the power xy, and we might need this xyx. Okay, so xyx will be you have this xy, and then take derivative. This will be again same as this xy e to the power, sorry, it will be y e to the power xy plus xy squared to the power xy. So in this case, you will see this fx xy is equal to f of yx. So we will have the same this derivative. So whatever this will be also equal to f of yxx. All these things you will see. Okay. So when you find, so what will be then our function? So this what how we can write this f of xy then will be f of 1 using Taylor's theorem, f of 1 plus x minus 1 times fx at 1 plus y minus 1 times fy at 1 and it will keep on going. Okay, so we'll see the thing. So what will be f of 1 see. Now f of 1 is nothing but e to the power 1 times 1, because this, see, e to the power xy. So it will fx and fy, they will be also e. So f of, so equal to e f of x at 1 that will be also e equal to f of y at 1. But when you come to this f of f of xy, f of xx, those will be also 1 1. Okay, right? So this is also 1 1, or sorry, e, only e. So f of xx at 1 1, that will be also e equal to f of y at 1 1 equal to f of x y at 1 1. All these things will be there. Okay, so then what will be the answer? The answer, not, so your approximation is f of xy will be, first term will be f of 1 1 plus x minus 1 times f x at 1 1, right, plus y minus 1 times f y at 1 1 plus 1 over 2 factorial times x minus 1 whole square fx x at 1 1 plus x minus a times y minus a times f xy at 1 1 plus y minus 1 whole square f y y at 1 1. So if you put, and it will keep on going, so third term also I am not writing, that also you have to include. So then, so I'll show that how the answer will see. This e, this both are e, so it is also x minus 1 times e plus y minus 1 times e plus 1 over 2 factorial e. If you take common, see fx at 1 1, all these things will be e, so x minus 1 whole square plus x minus 1 times y minus 1 plus y minus 1 whole square, all these things, and the third term will be there. So third term you can compute and you can find that this is the solution I have written. See, you see this, we get the same thing, e times 1, e times x minus 1, e times y minus 1, e times all these three terms. See, up to this we got. See, that's what we got. So third term, you just try to find out the third term. So third term will be 1 over 3 factorial times uh, f of x triple x at 1 1. So this times x minus 1 whole cube plus x minus 1 whole square times y minus 1 of f x x y time at 1 1. See, this x has two second order, so f is second order, so here will be also second order. So similarly, x minus 1 time y minus 1 whole square times f x y y at 1 1 plus y minus 1 whole cube f x, sorry, f y y y at 1. Okay, that will be your third term, and you know all these derivatives how it will be. So what are the values, you know this from here. It will be 2 times 1 will be 2 times 1 will be 1 time, like that. So then what you will get is this last function. So the, yeah, so this will be the last term will be like this. Okay, so that's why you will see 3 by 2, and will, all these things will come due to this f of x y x and all, so it will have 2 times e. Okay, so you have any doubt here? So how to, what we have done is how to approximate the function of two variables by a polynomial of degree some n degree, nth degree polynomial. So here mainly the question was to uh, write a Taylor series expansion of e to the power xy. So this is mainly the Taylor series. The solution is the Taylor series expansion of the xy. Also, you can see that this the solution is written. The solution which is written, that is nothing but a polynomial of degree 3, two variable polynomial of degree 3, which is approximating e to the power xy, like it, which is approximating e to the power xy up to 30 degree terms. So which will give, this will give you quite a good approximation, and we will see also how the error is, how much it is approximating. That not for this question, so for some other question we will see how the error comes, and you will see the term, you would take more terms, the instead of third degree terms you take 4th degree 5th degree terms, then you will see the better approximation. It will approximate the function like better. Okay, so yeah, now we'll, that's what we said, is how to take how to integrate this in sine integration of sine x square. So it's not easy, sine of x square, right? Can you just can you quickly tell me how to integrate this function? Anyone? Yeah, so if not, then like we can approximate. If we can't find a exact solution, we can try to approximate the function sine x square and then we can integrate, right? So see, sine of x is nothing but x minus x cubed by 3 factorial plus x to the power 5 over 5 factorial and keep on going. It is just a plus and minus and it will keep on going, okay, right? So then what will be sine of x square? That will be x square minus x to the power 5, because we are putting x square, I mean, no, not 5, it will be 6, right? So don't. So it was 6, I mean, you are taking cube of x square, which is 3 times, so over 3 factorial plus x to the power x to the power 10, right? Over 5 factorial and keep on going, right? Let's write a few more terms, then you will understand. And what will be that? X square minus x to the power 6 by 3 factorial plus x to the power 10 over 5 factorial uh, minus x to the power 14 over 7 factorial and keep on going. Okay. Now if so it is a series. So now if we integrate, so the integration will be in for each this x square dx minus x cube over sorry x to the power 6 over 3 factorial times dx, let's start like this, whatever we have. So what will be there? X cube by 3 minus x to the power 7 over 7 times 3 factorial, right? Plus the for x to the power 10, it will be x to the power 11 over 11 times 5 factorial minus x to the power 15 over 15 times 7 factorial, and it will keep on going. So what will be your integration over sine x square? That will be sorry, something is missing, I think. No. No, it's fine, right? So that you can write as this series. So series is nothing but x cubed by 3 minus x to the 7 by 7, like that it will. Okay, so let me write it in a summation form. N equal to 0 to infinity. First of all, we have to keep x to the power. Yeah, so what will be this? So 2 when not 2n plus 1. Okay. So 4n plus 2, right? Sorry, no, not 4n plus 2. 4n plus 3, right? So the x will be 4n plus 3. So n equal to 0, it is 3, n equal to 1, it is 7, n equal to 2, it is 11, n equal to 3, it will be 15. Okay, so it's fine. Then what will have? You have this 1 over, so this will be over, so n equal to 1, so 2n plus 1 factorial, okay, times 1 over 4n plus 3, right? So this will be the solution of the sine x square. So if you take integration of sine of x square, this will be a series which looks like this, right? If we put n equal to 0, first term will be x cube over x cube over x cube over 3. So and the second term will be n minus 1 whole to the power n also. Okay, minus 1 whole to the power n. Yeah. So when n equal to 1, it is so then it will be, now it is fully correct, right? So just check it, is it okay? So you can take up to some finite terms, so you can see the like kind of good approximation. At least you can approximate the integration of sin x square value. You can know that it is kind of going to some point, or is it's near to some point. Okay, up to fourth order approximation, fifth order approximation. How much like the more approximation you take, the value will be more. Like the like you will get the more appropriate value. Okay. So this I said this to find out the definite integral, so approximate to approximate integrals mainly. So it will be useful to approximate integrals, approximate functions. You have seen already, these two already seen. So we'll see later on how much it is approximate is embedding also. Okay. Second question. So it is the now time came to check that what is the error while approximating. Okay. So read the question properly. So I'll give you 1 minute and I will be reading here also, and I give you 1 minute to read the question. See, f of x y is equal to y cube plus 4x square y minus 5x y plus 7 is approximated. It is already taking already telling that it is approximating up to second order by the Taylor's polynomial about 1 2. Then what is the maximum error in this approximation at a point in the neighborhood, this in the square this. So this square is nothing but uh, this is a rectangle which is like where this 1 2 also lies in that point. Okay, so 1 2 also lies at that in this domain. This is a domain where you have to find out the how much the maximum, what is the maximum error if you approximate this function by the Taylor's series expansion, Taylor's polynomial up to second degree. Okay, that is fixed. So you know f of xy, when it is approximated up to second degree, the error term will be, so how it will look like. So about a point 1 2. So this will be 1 2 plus x minus 1 times fx at 1 2 plus y minus 1 times fy at 1 2. So all of you please try with me, so that these are calculative. So if I am making mistake, you can also tell me, right? So now plus 1 over 2 factorial x minus 1 whole square fx is 1 2 plus x minus 1 times y minus 2 times f xy at 1 2 plus no x y minus 2 whole square f of y at 1 2 plus this r and r two terms. So this will be the error mainly. So you have taken up to second degree. Now it will be a error. So that r2 also we know how, what is r2, right? So the R2 is like, R2 will be nothing but 1 over 3 factorial, right? So R3 we see this I already written, so don't need to check. So R3 will be 1 over 3 factorial times this quantity. So 1 plus theta times x minus 1 plus 2 times theta times 2 plus theta times y minus 2. So yeah, so that then what you will see, so f of x at 1 on, you have to find out, see this f of x at 1 on, you have to find out, sorry 1 2, f of 1 2 we know already. So f of x at 1 2, what will be this? So fx, f, what is f? F is nothing but f is nothing but y cube plus 4x square y minus 5xy plus 7. So fx will be 8xy minus 5y, right? So fx at 1 2 will be 16 minus 10 is 6. Similarly, you find out f of y at 1 2. See, I have written already f of y at 1 2. So it's not, I think, written. Okay. So f of y at 1 2 will be, see, f of y, we have find out this. F of y is 3y square plus 4x square. So fy at 1 2 will be 12 plus 4 minus 5, okay, 11. So it will keep on going like this. So it will be 11, all these things. We have fx, x at 1 to all these things. So now the thing is, we don't need to find out all these. You can find out, you can find it and right. But main, what is the thing? We have to find out the error here, R2. So why to find out all these things? You can find out, but no need to do those things. So what you will find out this here, this 1 over 3 factorial times this x minus 1 whole cube f triple x at 1 2 plus x minus 1 whole square times y minus 1 f x x y at 1 2 plus x minus 1 times y minus 1 whole square f x y y at 1 2 and plus y minus 1 whole cube f x, sorry, not x, y triple y at 1 2. Now we see what are the values of fxx. The fxx is 0 and fxxy is 8, fxyy is 0, fyy is 6, right? So if you put all these values 1 over 3 factorial, fxx is 0, so first term will not be there. Then fxxy x xy, that is 8, so it will be 8 times x minus 1 whole square y minus 1 plus fxyy is also 0, right? Fxyy is also 0 and fyy is 6 plus 6 times y minus 1 whole cube. That is your error. So yeah, so what you got, the error is, some mistake is here. So anyway, so the error here is the error is 1 over 3 factorial times x minus 1 whole square y minus 1 and 6 y minus 1 whole cube. Now we will see this x minus 1 is maximum 0.2, y minus 2 is also maximum 0.2. So what will it will happen that yeah, I'll write it, x minus 1 whole cube, this is xxy. So if you write, if you try to write this one, will be this is 8, how it is 8, yeah. So the whatever you will get, this x minus 1, this will be 0.04. So try to find out there. So it will be, so 1 over 3 factorial and this 6 will go. So y minus 1 is also less than equal to 0.2 and x minus 1 also is less than equal to 0.2. So you use this to, so that then you will see that the error can maximum be 0.04. So 0.0 it cannot go beyond 0.04. Okay. So when you are approximating this using when you are approximating this using the second degree Taylor's polynomial, then the error can maximum be 0.04. So if you do this same question for the Taylor series expansion, Taylor polynomial of degree, let's say fourth degree, then we will get the less maximum error. So maximum error will be less than 0.04. So you can approximate in a better way. Okay. Is it okay? So last one you have to mainly just calculate. You put y minus 1 is less than equal to 0.2. So this modulus of this one is there. So you take y minus 1 whole cube, that will be also less than equal to 0.2 whole cube, and then x minus 1 whole cube whole square will be less than equal to 0.2. Means this two term will be 0.2 whole cube, and plus this 1 over 3 one will be 8 times 0.2 whole cube, and one will be 6 times 0.2 whole cube, and 1 by 3 factorial. You have this is calculate and you get it. Answer will be 0.04. Okay, so this was repetition repeated. So we don't do this. So now we'll move to maxima and minima. So any doubt up before maxima and minima? So we'll start maxima minima. But before that, if you have any doubt in the previous like the previous part, then you tell. So if not, let's do this maxima minima problem. Okay. So mainly how you find out the maxima minima of a function of two variable, mainly function which is going from R2 to R. So we say a critical point of a function if the gradient of the function at that point is 0. Here gradient of f is written as a 0 factor. That implies fx at ab is equal to 0 and fy at ab is equal to also 0. So to know the maximum minima, the first of all the function has to be critical point, and that at that critical point function can have local minima or local maxima or neither also. It can be nothing also, that also can be. Okay. The sufficient condition for maxima at the critical point are f of x, the derivative of f of x with respect to x has to be less than 0. Means we say f of x double x is less than 0, and this f of x time f of y minus f of xy square has to be greater than 0. So these three things are like these two things. If it happens, then it will be maxima. Otherwise, if this f of x is greater than 0 and f of x y minus f of xy square is greater than 0, then that will be minima. Otherwise, if it's less than 0, it will be saddle point. These three are very much important. So this things gives you the point, and the I mean when you get a point where the function has maxima or at least the local maxima, then you get to know that in the neighborhood of that point the function will have the maxima. So mainly if we think in one variable, a function can be like this, and this, suppose up to this. See, here also it has a maxima in a small neighborhood of this point, small neighborhood, this is a maxima, right? Here also it will be a maxima, here also it will be a maxima. So these are called local maxima. So these three gives you the local maxima point. So these three will be critical one. So here also again this will be minima, this will be minima. These are the local minima or local maxima. So what will be the absolute maxima, absolute minima? That will be the maximum of those local minimas. So absolute minima is nothing but a local minima also. But all the local minima or local maxima are not absolute maxima or absolute minimum. Okay. So, but anyway, these three are very important in knowing the function behavior and maximizing the problem, minimizing problem. This will be very important. So we'll see that how they are playing crucial role in doing the problems. Okay. So, yeah, so let's move to the thing. So, this is your first question. So, first question says that find and classify all the critical points for the function f of x y is equal to x to the power 4 plus y to the power 4 minus 4 times xy. So, what you know, if the critical point, then f the partial derivative of the function f with respect to x should be 0 and the partial derivative of the function f with respect to y, that has to be also 0. So let's make f of x at xy, what is that? Then it will be 4x cube minus 4y, right? We take derivative, then it will be y. So f of, and what will be f of y at xy? That will be 4y cube minus 4x. Okay. Now, so we are trying to find what is the critical point. So if you want to know the critical points, then if AB is a critical point, then at that point the derivative will be 0. So let's take f of x equal to 0 equal to f of y. Then we solve, and then whatever the point we will get, this will be the critical points, right? So this will implies 4x cube, sorry, 4x cube minus 4y is equal to 0, and fy equal to 0 will give you 4y cube minus 4x equal to 0. Now this implies that x cube equal to y, and this gives you that x equal to y cube. Okay. Now what is your x cube equal to y, and y equal x equal to y cube gives what does that give? So x cube equal to y gives y cube to the power cube is equal to y, because x equal to y cube also we are using this two from 1 only, from 1. So that gives you y to the power 9 is equal to y, right? So y to the power 9 equal to y means y times y to the power 8 minus 1 will be equal to 0. That implies y times y square minus 1 times, so it will be y to the power 6 plus, uh, I think it will be y square plus 1, right, is equal to 0. What do you say? So it will be equal to y. Yeah, I just check it whether this is so. If we have written in form of x cube minus y cube is nothing but x minus 1 time x cube minus x plus xy. Uh, sorry, not x cube, x square. Okay, so this will be, so x square will be 9 x to the power 4 So what will be this? Mainly I am writing in form of a cube minus b cube is nothing but a minus b times a square minus ab, sorry, plus ab plus b square, right? So that form I have been writing. So y squared to the power, like not y square then, so it will be y to the power so how you write it? No, so let's write in a like better way. Okay, I'll take. So we have come up to this. Okay, remember. So y times y to the power 8 minus 1 is equal to 0 is given. Y times will do y times y to the power 8 minus 1 is equal to 0 implies y times y to the power 4 minus 1, right? Y to the power 4 vertical 4 plus 1, okay, is equal to 0. So this cannot be equal to 0, so that implies y times y to the power 4 minus 1 has to be 0. That implies y times y square minus 1 times y square plus 1 equal to 0, but y square plus 1 cannot be 0, real value from the solution we are finding. So that implies y equal to 0, y is equal to plus minus 1. And when y equal to 0, then x will be equal to 0 because we have x equal to y cube. From there, what we get this when x equal to 0, y equal to 0. And when x equal to 1, y equal to 1. When x equal to minus, sorry, so when y equal to minus 1, x will be also minus 1. So the points are 0, 0, 1, 1, and minus 1, minus 1. All are critical points. So do you understand how one can find out the critical points of a function? Okay. So once you find out these critical points, now you have to show that. See, that's how we got. That's what we got. X 0, 0, minus 1, 1, and minus 1, minus 1 are critical points. Now we have to show that the at these critical points, which one of them has maxima, which one will be minima, which one will be saddle points, and all. Okay. So what will be f of f double x? That will be, so what is fx? First of all, fx is given to you. Fx is, I think we have found out. Yeah, this is fx. So f of x will be 12x square, right? F of xy will be minus 4. F of y will be, because all this thing we need to know. F of y will be 12y square. Okay. So then f of x at 0, 0 will be 0, right? F of xy at 0, 0, that is always constant, that is minus 4, right? That's minus 4. And f of y at 0, that is nothing but 12 times x square, that is 0. So what we get, fxx 0 at 0, 0 times fyy at 0, 0 minus fxy at 0, 0, that square is nothing but negative of minus 4 whole square, which is negative of 16, which is less than 0. What does this imply? This implies you don't need to go to the maxima or minima. To be maxima or minima, this should be greater than 0, right? So when it is less than 0, so 0, 0 is saddle point. Right? So see, you can check here. This is the see, this has to be less than 0. So if it is less than 0, then it is a saddle point. So I'll do for one more point, so it may be 1, 1. Then we'll see like at 1, 1 how the function is behaving. Okay. So let's do it here maybe. So what will be fxx at 1, 1? This is 12x square, with 12. So similarly, if y at 1, 1 will be 12, right? Because you see this is 12x square and 12y square. And f of xy will be minus 4, right? So if you multiply 12 times 12 minus 4 whole square, which will be 144 minus 16, which is of course greater than 0. So once it is greater than 0, it can be maxima or minima. It can be maxima or minima. So then how to find that? So we have also seen that fx6 at 1, 1 that is 12, so which is greater than 0? So it will be minimum. So at 1 1 f the function will have minima, local minima, mainly the local minima, okay? Because you see this f will have minima at 1 1, also f will have minima at minus 1 also. So the value, the minimum value will be the f at 1 1, whatever the value, but the minima will have at 1 point. That's the thing. So you see here we have classified all the critical points. So that we have found out all the critical points and how they are, means what are their classification. Okay. So now it's time to find out first of all of you try to find out what the critical points first of all. So you make fx equal for this function fx equal to 0, f of y equal to 0. So what is that giving? What is the solution you tell? Like quickly, please do it. Like 5 minutes. I'm giving you. If you're trying, please let me know. Otherwise, I'll proceed. Okay, no problem.
Sir, I am only getting 4,4.
Okay. Anyone else? Are you getting some other point than 4 or no? Okay, so it looks like people are on tell anything or maybe in the middle of the calculation. So anyway, I'll do that. What will be fx equal to 0? Fx will be, what is fx? It will be 8 minus 2x. Oh, it is easy. So that's why x equal to 4. And I mean, let's write it properly. I mean, I'll take this one here, maybe. Okay, so it will be same thing, right? 8 minus 2y is equal to 0. That will be like y is equal to 4. So what this implies, fx at 4 4 is equal to 0, and that also fy it is equal to 0. So now tell me what is at 4 4, how is the function behaving? I mean, whether local minima, local maxima, or saddle point. Now try that.
So local maximum.
Local maximum. Okay,
Yes.
so fx6 will be, what will be fx8? That will be minus 2. Fyy will be minus 2. The independent of any point, and f of xy will be 0, right? So then what will happen? I mean, f of x is minus 1, sorry, minus 2, and f of xy is equal to 0, f of y is also minus 2, right? Then if you multiply minus 2 times minus 2 minus 0 square, which will be equal to 4, which is greater than 0, okay, greater than 0, and then f of x at any point anyway here the independent points which is less than 0, right? So local maximum. Did you get local maximum, Ananya?
Yes, sir.
Okay, good, great. So yeah, that's what we have to put local maximum, okay? And the only critical point is here is 4 4. So these are very important questions, okay? These type of questions may come in your exam, okay? So try to do for this at least. So I think after this I will go to some like better questions. I mean better in the sense with the constraint and all we will see. Okay. So yeah, let's do it for like do it. I'll give you a few minutes. Okay. Then I'll do it, and after that we'll have the like interesting question, more interesting questions. I understand these are kind of same questions. We are doing 2 3 questions, but it's good for you. It's a little different type of, I mean, different functions, but you can practice. So first of all, find out the classical. Sorry, find out the critical points. Okay, fx equal to 0. Let's start it properly. For uh, critical points, fx will be 0 and fy has to be 0, and then you have to solve that. So solve this fx is 0 and fy equals 0, then you will get the points. So what is fx? Will be 3x square minus 3. Fy will be 3y square minus 6y. Fx equal to 0 then imply then f of x equal to 0 imply x is equal to plus minus 1. Yeah, and this one, then f of y is equal to 0 imply y times y minus 2 is to be 0. That simply y can be 0 or 2. So tell me what are the critical points then? From here, what will be the critical points? What are the critical points?
1 0 1 2 minus 1 0 minus 1 2.
Great. Yeah. So it's not only some 1012 or something. Okay. Don't make mistake here. You may get confused. Okay. It will be 10 for x. So all the points are x equal to plus minus 1. For plus minus 1, both minus 1 and 0 also are critical points, and minus 1 and 2 at 2 also. So 1 2 and minus 1 2. So these 4 points are now more critical points. These are the set of critical points. Critical points. Okay. 1 0 minus 1 0 1 2 minus 1 2. Okay. See, yeah, you will see 1 0 minus 1 0 minus 1 2 1 2. So it's now we are going to find that. So one of at least one point we will do. Okay. Other point you do by yourself because the solution is given. So fx at suppose we are going to find what is fx. Fx will be 3x square minus 3. So f of xx will be 6x. F of y is nothing but 3y square minus 6y. That implies f of y will be, what will f of y be? 6y minus 6. So what will be f of uh, yx or xy? That will be 0. So these are independent of points. Now at each point you try to find out the, so fxx times fyy minus f of xy whole square. This will be when xy is equal to 1 0. So let's write it here properly. Okay, leave this here. We'll try to find out because we have got all the points. So now we'll have f of xx times f of yy minus f of xy, that square, which will be uh, at, suppose at 1 0. So at 1 0. So when at 1 0 x equal to 1, y is equal to 0. So this will be x will be 6 time f of yy will be minus 6. All these things we are getting from here, okay? So don't get confused. Okay, so we are getting from here. So minus 0 square, so which will be minus 36. Now at suppose it's minus 1 0, okay, minus 1 0. So at minus 1 0 it will be 6 times minus 6 minus 0 square, which is 36. So similarly other 2 point you do, okay? So now at 1 0, this fxx dot fyy minus fxy square is what? It is less than 0, right? So it is not saddle point, it can have maximum or minimum. So max or min. So to know that what is that? So fxx at 1 0, what is that? Whether it is positive or negative 1 0, it will be 6 times 1, which is 6, which is greater than 0, right? So that implies it has minimum, local minimum. So at 1 0, local minimum at this point, okay? If you take at minus 1 0, then the fxx times fyy minus fxy square is greater than 0, because that is 36, nothing but value is 36, so it will be greater than 0. So saddle point, no need to check fxx there. So if x times f of x, if x times f y minus f x y square is positive, is strictly greater than 0, then you don't need to check f x x separately. You will just tell that it is a saddle point. So that's what I see, minus 1.
Sir, won't it be opposite when the difference
I
is?
think, sorry, yeah, I made a mistake. So it will be a, so 1 0. So it is okay. Let me just if I made a mistake. So f greater than, okay, less than 0 is a saddle point, okay? Less than 0 saddle point. So I get to sometime, like, I do mistake, of course, but because of confusion, okay. Let me go to where I did. The last question I made, that was correct. Okay, so this less than 0 mean, so guys, so I made a mistake. So this will be, yeah, so this will be at 0. So when it is less than 0, it will be saddle point, okay? So when it is greater than 0, so now we need to check that what is fxx at minus 1 0. So what is that? Fxx at minus 1 0 is minus 6. So that is less than 0. So maxima, right? Is it correct now? Local maxima. Minus 1 0, yeah. Local maxima is minus 1 0 to be local maxima. And saddle points will be 1 0 and minus 1 2. So if you check at minus 1 2 also, this quantity will be greater than less than 0. So this, that's how we can show that. Okay. Yeah, now it came to one of the good question. Find the absolute maxima and minima values. So now we have to find an absolute maximum or minimum. And at the point, so not at the point, over a domain, over a region bounded by this. What is this? Can anyone tell? What will be this bound, like region?
So triangular.
Not triangular, it's just triangle, of course. Yeah, it's triangle, right? Let's draw. See the what is x equal to y line? I mean, it will be like this. Okay, it is y equal to x or x equal to y line. Now, what will y equal to 0? I mean, this it is y equal to 0, right? And x equal to 2 will be somewhere here. So x equal to 2 line. I mean, it's like this. X equal to, so this will give you a nothing but a triangle, right? Yeah, I mean it's a triangle, this type of triangle. There's a so in this region mainly you have to find out the absolute minima or absolute maxima. Sorry, yeah, absolute minima and absolute maxima of the function f of xy. Okay. So how to do that? This is a general procedure. Did you go through the notes or like lecture video by Professor Jitendra Kumar? So if you went through, then you know. Otherwise, I can also explain a little bit here. So what do you say? Who is there? Should I explain a little bit? Not much things are there. I mean, just I can also tell, right? If it's not needed, I will not tell. That's why I'm asking. So general procedure is there. So what we'll do to know absolute maxima or absolute minima of a function over a region, a bounded region, will first of all find the local maxima or local minima whether the function has in that domain. That we'll find. That is general. Sorry. So the general thing is, so if you try to find, so one point, so point one will be point one, try to find the local maxima or minima of the function xy in the domain, that domain. Okay, try to find out the maximum. Just that is usual procedure, you know. That is fx equal to 0, fy equal to 0, make fx equal to 0, fy equal to 0, and then find out those points. And uh, second you include boundary points mainly, and then so the thing will be this, like this. See, I have written it here. So first, consider the boundary points, the points where local maxima and can minima exist, and then in usual way find out the local maxima and minimum. Then try in three cases through each boundary line of the problem and find the local maxima for one variable function. So we'll see that how it is happening. Okay. Okay, so let's do this. So what I'm telling is try to find out the local maximum or local minimum of the f of xy, and then include the boundary points. So remember this, including the boundary points. That's all. That maximum I can tell now. So you just include the boundary points and try to find out in the boundary where you find the maximum or minimum each in the boundary. Okay, then it might happen that absolute maxima. See, there can be many maxima. So maybe you are getting 2 3 local maxima. One will be might be so I think this is not saying one might be here, one might be in this boundary, one might be in this boundary. So mainly if you have these 3 points of, let's say, A, B, C, then the absolute maxima, if you have in ABC, you have at ABC, if you have local maxima, then will only 2 3 points are right. This, so that will give you the absolute maximum by taking the value. So we'll find out f, what is the value of f at A, we'll find out f at B and f at C. So we can then see that which one is the maximum. two, 3 points are there. So whichever will be the maximum, that will give you, that will be the maximum of these three will be the absolute maximum, right? So let's now do the, I mean, like how we can do this one. Okay. So our question is, our f function is f of x y is equal to x square plus 3y minus 3xy, and our domain is this y is equal to x. The domain is already written also, y equal to 0 and x equal to 2. Okay, so first we do like usual way. If x equal to 0 implies 2x minus 3y is equal to 0, right? And if y is equal to 0 gives 3y minus 3x equal to 0. That implies y is equal to x, and from these two, from here you get 2x equal to 3y, and from here you get x equal to y. That implies x equal to y, if you put, it will be x equal to 0, y equal to 0. The only solution is 0, 0. So f at 0, 0 is 0. That we keep in mind. Okay, and that will be only point, only critical point, and that the value, whatever, if it's maximum or minima, we just we evaluate the value and give the f of 0, 0 is 0. Now through the each boundary we'll check. Okay, so let's through y equal to 0 line, through y equal to 0, whether it is like what's the maximum, like the which point it has maximum. Okay, that we will find. So when through y equal to 0, f of x y will be f of x 0, that is nothing but x square. So now if you take f of x, I mean this is nothing but a gx, you can think. This is no, this is nothing but a one variable function. Now if you take g dash x, that will be 2x, and for a local, for your maxima, you just make g dash x equal to 0, maximum or minimum. So that will be g dash x equal to 0 imply x equal to 0. So through y equal to 0, only point where it can have maxima, that is x equal to 0. So that is again you are getting 0, 0 point. If this through this line, if the maximum, local maximum or local minimum exists, that maximum can be at 0, 0. So again this is this same thing. So this will be 0, 0, f0, 0 will be 0. So that's what I already included. Now through anyway we are going through each line, right? I had said. So mainly we are going through each line. Sorry, I know this. Yeah. So mainly like first this line, then this line, then this line. We will be going like this. Okay. So yeah. Now through x equal to 2, right, line. And that is nothing but a boundary, not because of some line, it's a boundary of the domain. So through x equal to 2 line, the function will be f of x, sorry, not f of x, it will be f of 2x. That is nothing but, what is f of 2x? Is 4 plus, so no, not 4, 2x, 2y, okay? So don't make mistake. So 2y will be 4 plus 3y minus 6y, right? 3 times 2, 6 minus 6y, which is nothing but 4 minus 3y. So now I assume that this is nothing but a function. Let's say it is fg h of y. Now h dash y will be then minus 3, which is not equal to 0. So through this line x equal, so this h dash y is equal to minus 3 not equal to 0 mean h has no local maxima, no maxima or minima, local maxima or minima for one variable function. So this f of 2y will not have any local maxima or minima that implies through this line x equal to no local maximum or minimum, no local max or min. Okay. Now once you're done with that, then we'll go to this through y equal to x line. So through y equal to x line, it will be f of x x. F of x y will be f of x x. That is nothing but x square plus 3x minus 3x square. Sorry, x square plus 3x minus 3x square. X square plus 3x minus 3x square. Yes, that is nothing but 3x minus 2x square. So that is nothing but a function gx, which is nothing but 3x minus 2x square. And if you make g dash x is equal to 0, g dash x equal to 0 will give you x equal to 3 over 4. So the point you get here is 3 over 4, 3 over 4 means at this point also function can have maximum or minimum. So we find out 3 over 4 at 3 over 4, then what will be the number? So I mean 3 over 4 over 4 over 3. Yeah, 3 over 4 only. So f 3 over 4 3 over. So if we check the function, the probable points are 0 0 2 0 2 2 and 3 by 2 3 by 2. Okay. Let me check whether I have made mistake here. I don't know whether these are 3 over 2, 3 over 2. I think 3 over 4, 3 over 4. That is what I am getting. Let me check once. So what is f of x? Y is x square plus 3y minus 3 xy. When y equal to x, it is 3y minus 2x square, right? Because it is x square minus 3x square. So it is 3x minus 2x square, which is nothing but gx will be 3 over 4. Right? Because g dash x will be 3 minus 4x, which will be 3 over 4, 3 over. So if 3 over 4 and 3 over 4 will be what? Some value. This will be some value. I mean, let's try. Okay, let's find out also. 3 times 3 over 4 minus 2 times 9 over 16, right? So that will give you 9 over 4, 2 times 8. So that will give you 9 times 1 over 4 minus 1 over 8 will be 1 over 8, right? Yeah. So it will be 9 over 8. One is you have 9 over 8. One you have at 0, 0, what you have 0. And also you have to consider the corner point. So although they are not there, so this corner point also you have to include. So 0 is 2 0 also you have to find out. So you have this number also, you have this number also, and also find out f at 2 0 and f at 2 2. So what will be f at 2 0? 2 0 will be 4. At 2 0 it will be 2 0 will be 4. F at 2 comma 2 it will be 4 plus 6 14. Sorry, 4 plus 6 is 10, minus 12 is minus 2. Okay, minus 2. So if you consider all these things, you will see the so it is 4 and minus 2. So this minus 2, you got minus 2, right? Here minus 2 we got. So this will be local minimum, right? And this, it is 9 over 8. So what are the values you got? So at 2 2 it is minus 2. Another value you got 9 0. Another you got 9 over 8. Another you got 4. So local minimum is minus 4. maximum is 4, and at 2 point it will have local absolute maximum, and at 20 point it will have local maximum. Okay, that's a thing. That's how we got the answer. We have reached. Okay, I think this will be 3 over 4. 3 over 4. You just check it. If you find mistake, then please comment maybe there in the uploaded video, so that people can check. Or you inform me. I'll comment there. Okay, so we have a thing to correct. I mean, we are uploading a video, so you can put it there. Okay, I think it will be 3 over 4. 3 over 4. That's what we got for now. If some mistakes is there, I will update it in the video, the uploaded video. So, but otherwise, this is the answer. So now we'll do eighth questions. Eight questions. So find out the local maxima minima values in this disk. Now you don't have any corner and all to include. You just you have to find in the disk. For a disk, it's the boundary will be the circle, only one point only, right? So in this is x square minus this r is equal to 1. So this 0 point mainly. So then you find out in this domain the local maxima or minima of this function. Can you please try? I mean, I will write x square plus y square minus xy. Yeah. So am I audible?
Yes, sir.
Okay, okay. So I have got a notification that I was disconnected or something. So this is the function mainly, your function, and on the domain, in this domain, you have to find out the maximum minimum. Can you do it? Can you try? You want to try, or I will do it? If you want to try, then I will give you few minutes, 2 or 3 minutes maybe. What to do? How to proceed? Tell.
So first we will find the critical points on the boundary where we will take strict inequality, and we will do by normal approach of f of x and f of y, and then we will do for inside the boundary we will have to use Lagrange's multiplier.
On the boundary, you can do Lagrange multiplier. Also, without doing Lagrange multiplier, we will try. Okay, that can you do without doing Lagrange multiplier also? That's a good good suggestion, I'll say. But we can I did not anyway still introduce the Lagrange multiplier. You can do with Lagrange multiplier on the boundary only, and for inside the domain you have to do the same usual analysis of the maximum minimum finding out. So that too you can do, but there will be two different thing mainly you have to use. So I don't want to do in this question. So what I say, first of all, usual way we will find out what is fx will be 2x minus 1, fy will be 2y minus 1. So fx equal to 0 equal to f of y will give you x equal to half, y equal to half. So one point we got, so that is half and half. So keep this one in mind, that half 1 point we have. So that can be maximum or minimum. So we don't need to find out now. Okay. So f of now that's the only point. So and this point is inside the domain, right? Inside circle. So 1 by 2 square plus 1 by 2 square will be 1 by 2 only, right? That is less than 1, so it is inside the circle. So this and that's the only point where inside the circle, just inside the circle, not on the boundary, inside the circle, that's the only one point. So on the boundary, now on the boundary, so like we did in the case of triangle, we could go through each boundary properly because it was very nicely written, and x equal to 0, y equal to 2, sorry, x equal to 0, y equal to x, y equal to 0, x equal to y, and x equal to 2, right? These three paths were there, we could go. Now here the problem is that thing is not there. Now can anyone tell how to proceed for that? How do we
Sir,
proceed?
maybe we can substitute when if it is on the boundary of the circle, that means x square plus y square is equal to 1. So maybe we can substitute that in the function.
But Ananya, so what will happen? This will give you this x square plus y square equal to 1, right? If you substitute x square equal to 1, so f of xy, of course, f of xy will be x square plus y square will be 1 minus x minus square root of your 1 minus x square. All this thing will come, so that will make your life little difficult again, right? You might do little difficult, I think. It will be little difficult if you do in this way, right? Again, so you have to find this a gx function, and you have to find out g derivative of gx, and all this thing will be little difficult. Uh, but it will come. The answer will come, but it will be difficult. So what I am telling is f of xy you can write as a vector. So which is r of means rt. That rt is nothing but vector which has r cos theta and r sin theta. Sorry, r cos t, r sin t with, I mean this is r vector, and the thing is t belongs to 0 to 2 pi. Is it okay? That can we do? You can do, right? Any question here?
No, sir.
We cannot do. Can't we do this transformation? So because on the boundary your x will be r cos theta, means here t I am taking, y will be r sin theta, right? That's all. And whatever theta then be, this it will be r cos theta, r sin theta, but on the boundary r equal to 1, right? So r you can erase this. Fully correct now? I mean, do you understand? So for any point inside in the circle, this will be, you can parameterize like this, but as here r equal to 1, so it will be cos theta sin theta. So then what you get, x square plus y square will be 1. So because cos square t plus sin square t will be 1, so 1 minus cos t minus sin t plus 1. So it will be 2 minus sin t minus cos t. Right? Are we doing? Okay, question 88. So you see, you will get the one probable point we got. So another one we have. So f of rt we got as 2 minus cos t minus sin t. So this is nothing but now a function of one variable. So to find our daily maxima, so we do g dash p, that is nothing but sin t minus cos t. So g dash t is equal to 0 gives you sin t minus cos t. Sin t is equal to cos t. And when that will happen, sin t is equal to cos t, or sin t equal to cos t implies tan t is equal to 1. Tan pi by 4 is 1. Tan 5 pi by 4 is also 1. Tan 9 pi by 4 also 1, but 9 pi by 4 is not in this t range. T should be belongs to 0 to 2 pi, right? So t can be from here, t can be pi by 4 or 5 pi by 4. So what are the point you got? 1 by 2, 1 by 2, and so what are the points you got here? I will somewhere I will summarize maybe. Let's write it here mainly. So 1 by 2, 1 by 2 you got, and t equal to 5 pi t equal to pi by 4. That implies it will be 1 by root 2, 1 by root 2, because the point will be cos t sin t. So it will be 1 by root 2 and 1 by root 2. And t equal to 5 pi by 4 will be minus 1 by root 2 minus 1 by root 2. So mainly you have to find the value at these points and then tell that where the maxima lies. See, this is the, we have to find maxima and minima. So let's do also, no problem. So it is, the answer is given that 2 plus root 2 and half. So f at 1 by 2, 1 by 2, it will be 1 by 4 plus 1 by 4 minus 1 by 2 minus 1 by 2 plus 1, this will be half. F at 1 by root 2, 1 by root 2, that will be 1 by 2 plus 1 by 2 minus 1 by root 2 minus 1 by root 2 plus 1, that will be 2 minus root 2, right? So now if you take f at minus 1 by root 2 minus 1 by root 2, that will be half plus half plus 1 by root 2 plus 1 by root 2 plus 1, that gives you 2 plus root 2. So what will be the bigger? So biggest one will be this. So absolute maxima will have, if will have absolute maxima at minus 1 by over square root 2 comma minus 1 over square root 2, and the value is 2 plus root 2. And f will have absolute minima in the domain, this domain at 2 to 1 by 2, 1 by 2, and the value is also 1 by 2. Is it okay?
Yes, sir.
Okay. So if that is so, then we will move to now this question. So here you don't have any that domain thing. So you have only constant, which is your line. So here it will be easy to use so-called Lagrange multiplier. So what Lagrange multiplier, what is the method is that if you want to find out the optimal value of a function and where given relation of xy is there, which is called a constraint, then you take f like another function and write as f of xy and plus lambda time constraint. Lambda times constraint. Okay. Then you try to find out the local maxima and minima for this capital F. And that will be the optimal value or maximum value of this thing for the function small f of xy. So now let's do it here. So for our case, f of xy will be x square minus 3xy plus 12x plus lambda times the constraint we will write as 2x plus 3y minus 6 because constant is this. Now what will be fx? Fx will be 2x minus 3y, is it 12x? Yeah, plus 12, sorry, plus 2 lambda, right? And fy will be minus 3x plus 3 lambda, right? And f lambda also we have to take here, okay? F lambda will be 2x minus plus 3y minus 6, okay? I mean, and you have to make sure that fx equal to fy, these are from Lagrange multiplier only, so make sure that this is equal to 0, then the optimal value you will get. And this equal to 0 imply f of y equal to 0 will give you lambda is equal to 3. Sorry, lambda is equal to x. And if we put lambda is equal to x here, what we will get? 4x minus 3y is equal to minus 12 because this fx equal to 0. And 2x plus 3y will be equal to 6. So from this two, what we get? X equal to minus 1 and yeah, I think x equals, see, if you just add it, it will be 6x equal to minus 6 equal to minus 1. So when x equal to minus 1, this will be, y will be 8 over 3, right? So and you got only that thing, so x equal to minus 1. So what you got from this solution, so fx equal to 0. So yeah, it's already written also. So we got everything correct. So fx equal to fy equal to f lambda. Sorry, f lambda is equal to 0 gives you x equal to minus 1, y equal to 3 over 8, or sorry 8 over 3, I think 8 over 3, and lambda equal to x you had. So 8 over 3, and lambda equal to you had x, so lambda also will be minus 1. So lambda value also we need. So then the optimal value will be, so now optimal value will be uh, at minus 1 8 over 3. So minus 1 8 over 3, right? Yeah. So x square, so minus 1 square. Now 3xy minus 3 times x time y plus 12x plus 12x. Sorry, 12x will be minus 1, right? Minus 1. Minus 1. That will give you 1 plus 8 minus 12 will be minus 3. This is your optimal value. That's what it is given here also. So check this one is here. I did also and it also. Oops. Yeah. So that is your solution with the questions here. Question.
So in this question, we don't have to find a critical point in the inside of the boundary. Like
No,
we,
it's that's why it is not written. You see, it is not written. 2x plus 3y less than equal to 6. It is not written, right?
oh, okay, yes, sir.
Yeah, it's only the line. Yeah. only line or
Okay.
only curve. When that type of things are there, you just do this Lagrange multiplier. It will be easy.
Okay.
Yeah. Any question here? Otherwise I'll do last question and we'll uh, end the session after that.
No doubt, sir.
Okay, so this is okay. Then let's read the next question, and this is the last question. We will finish it quickly. This is a interesting question. To find the points on the circle x square plus y square equal 80, which are closest to and furthest from the point 1, 2. So you have a circle and you have given a point which is, I think it will be inside the circle. Yeah, it is inside the circle. Then find out 2 points which are closest and farthest from the point 1, 2. I will do that. So, can you at least tell me that whether this will be a maximum minimum problem with a constraint? If so, what is the constraint? That is what I am asking. So, once you know that, then everything is okay, right? Mainly, you have to optimize or maximize something, and the function is given you the simple function x square plus a circle. But with respect to which constraint you have to find so that you will get closest or farthest point. For that, what you need? You need a distance function, right? So if you this question reduced to x square plus y square, maximize or minimize this with respect to or with the constant uh, x minus 1 whole square, because you have to take distance from this quantity. So x square minus y square, sorry, x square minus y x minus 1 whole square plus y minus 2 whole square with respect to this function, right? See, this is that's what is given. Maximize or minimize? Yeah, so maximize. Yeah, it's sorry. So because you see the max, you have to maximize the distance or minimize the distance. This maximize. This is a function g of x y, and maximizing or minimizing distance or distance square, that is same, right? So that's why I take like this. Otherwise, distance function will have square root. Okay. So with respect to x square plus y square is equal to 8. So you consider the function f x y. Any question? F of x y will be x minus 1 whole square plus y minus 2 whole square plus x square plus y square minus 80 times lambda. So please mute yourself if it's not needed. Okay. Anyway, so yeah, that's a hint for the solution. This is the max minimize the distance equivalent to the max minimizing the square of the distance, and thus the problem can be like this, and then you get the answer. You will see that answer. You will see like we got right. Means we have seen that how to proceed, right? Is it okay to leave it? Because I mean we have done the problem already. Means this type of problem we have done, but the question was from the language of the question. It is given in such a way that it's not, you will not understand how to like change it to in a mathematical way, so that you can understand and you can solve, right? And that thing we have done it here. This is the hint for the solution, and then you can find out fx a all these things, fx fy and capital fx capital fy and capital f lambda, and you find out the, then you will see that there will be maybe 2 points which satisfy capital fx equal to 0, capital fy equal to 0, and capital f lambda is equal to 0, and that gives those points are 4 to 8 and minus 4 minus 8, and you will get at those points. So these 2 points can be the maximum or minima, and you will see these points are on the circle. This will be on the circle, and if when you find out the distance, you will see 4 8 will be the closest point, 4 minus 4 minus 8 will be the 4 8 will be the closest one, and minus 4 minus 8 will be the furthest one. Okay, so we'll end this class here. If any question here in this question, any doubt here in this question?
No, sir.
Okay, so then yeah, that's the thing. So and yeah, if you have any question, you can ask. Otherwise, these are the book and references, the same things. And yeah, thank you for your attention. Thank you. We'll meet in the next Saturday again from 6 to 8, like we usually meet with the fifth class. I think that will be the fifth class. So your fourth class is over, like fourth tutorial session for me. Yeah, so thank you. Attend, and if you know how to like better way like to understand, you know that if I do some better, I can do some better way, then you tell me. I will try to do in some other way so that you can understand. So yeah, that's all, because you need to understand at the end. That, otherwise, just